uh, this portion. We have understood what is priority queue, what is linked list, what is singly linked list, what is doubly linked list, and all. Today we are going to see what are trees. A tree is a recursive data structure. So it is a recursive data structure that contains the set of one or more data nodes, where one node is designated as the root of the tree, while the remaining nodes are known as the children of the root. As you can see in this figure, this is the root, and these are all childrens. These are children. These are called childrens. Now, so one node is the root of the tree, while others are called the children. The nodes other than the roots are partitioned into non-empty sets where each one of them are called subtrees. So each of them are called subtrees. So these are the subtrees. So this is one subtree, this is another subtree, this is another subtree. So these are subtrees. Nodes of the children either maintain a parent-children relationship or their sister nodes. In this case, this A and B are parent children, B and E are parent children, whereas B, C, D, these are sisters. So this is what you mean by parent children and sister nodes. Now, in a general tree, a node can have as many children nodes as possible, but it will only have one single parent. So I believe you have understood it. This is the node, these are the children. Now there are a few terminologies which you need to understand. What is the root node? The root node is the topmost node in the tree hierarchy. So this is a root node. What is subtree? The root node is the one that does not have any other parents. So as you can see over here, does A have any other parent above it? No. So it is the root node. What is a subtree? If the root node is not null, then the trees T1, T3, T are called subtrees. These are called subtrees. Why these are called subtrees? Because they are not null. They have some data present over them. So these are subtrees. What is a leaf node? Node of the tree which does not have any children is called the leaf node. So a node that does not have any children is called leaf node. Example, this is a leaf node because it does not have any other children. It does not have any children. Leaf node is the bottommost node of the tree. So over here, this is a leaf node, this is a leaf node, this is a leaf node, this is a leaf node. Also, this is a leaf node because it does not have any other children. Leaf node can be also called as the external nodes. Now, what is the path? Path of the sequence of the edges are called path. As you can see over here, A, B, E. This is one sequence. Again, A, B, and F is one sequence. A, D, G is one sequence. A, D, H is one another sequence. So these are the sequences. These are the paths. Ancestor node. An ancestor of a node is any predecessor node on the path from root to that node. Suppose if this is my node, then this is my ancestor. So in this path, this is my ancestor. If this is my node, from this path, this is my ancestor. So this is what we mean by ancestor. The root node does not contain any ancestor. Obviously, in A will not have any other ancestor because nothing is above it. So it will not have any other ancestors. In the tree shown, okay, degree of a node is equal to the number of children. Degree is the number of children. Is the number of children a node have. What is the degree of node B? How many children does it have? It has 2 children, so degree is 2. What the leaf node will have 0. Why? Because leaf node does not have any children. This is a leaf node, this is a leaf node, it does not have any children. So what is the degree? Degree is 0, and so on. Level number. Each node of the tree is assigned a level number in such a way that each node is present at one level higher than its parents. So these are the levels which are mentioned. This is 0 level, this is 1 level. The root node is our 0 level. Root node is 0 level. The rest are level as they are found. The root node is present at 0 level. Now, as you can see, we can define. We can have a static representation of the tree. We have already seen how do we form structure. Structure can have multiple number of variables. So, structure itself is a variable, but it can contain multiple number of other variables. So, over here we have root color. Dynamic representation, as I told you, dynamic representations are required for linked list, which are better for memory point of view. So there we need to give them the pointers. We have to assign the pointers. Now, what are the types of tree available? There are 6 different categories of tree available. They are general tree, forest, binary tree, binary search tree. This is important. Expression tree and tournament tree. So we'll see one by one. First, let's see what is binary tree. Uh, the general tree stores the elements of the hierarchy in which the top level element is always present at the 0 of the root. So what is general tree? General tree stores the element in a hierarchy order. So there will be some kind of hierarchy in which the top element is always present at the 0 node. All the nodes except the root node are present at number of levels, as you can see over here. As you can see over here, this is the root node. It is a level 0, and there is some kind of hierarchy in this node, and all of them are having some kind of levels. So the nodes which are present on the same level are called siblings, while the nodes that are present on different levels exhibit parent-children relationship. So over here, these are siblings. These are siblings. B, C, D are siblings, where A and B are father and children. This is the father-children relationship. Now there is a special type of tree called the ternary tree. A tree in which each node contains 3 subtrees is called ternary. So this is special type of tree. Next is forest. So what are forests? Forest can be defined as a set of disjoint trees which can be obtained by how to obtain a forest. We can obtain forest by deleting the root node and the edges which connect to the root nodes to the first level of the node. So if this is my general tree, see how can I say this is general tree? Because there is some kind of hierarchy where this is the root node and it is having multiple number of other nodes. Now over here, if I remove this root node, then what will happen? I will have one set over here. So this is my one forest. Then I will have one set over here. This is another forest. Then I will have another set. This is the third forest. So I will have forest. So how can we form forest? We can form forest by deleting the root nodes and the edges which connects to root nodes to the first level. That's the root node. Then we have the binary tree. What is a binary tree? In the binary tree, each node can have at most 2 children. So this is fixed. So if we will call a tree binary tree if the node has at most 2 children. The node present at topmost level is called the root node, as we all know. A node which with 0 children is leaf node. We have already seen. Binary trees are used for expression, evaluation, and many other such examples. So binary tree, where it is used? It is used for expression evaluation. Now what is a binary search tree? Binary search tree is an ordered binary tree. All the elements in the left subtree are less than the root. Please remember this. Binary subtree is important. What is a binary subtree? In the binary subtree such a way that all the elements in the left subtree are less than the root. So if this is a tree, then in the left side all the elements are less than my root. This is what we say. We have mentioned over here. All the elements in the left subtree are less than the root. So all the elements in the left subtree are less than the root. Which is my root? A is my root. And elements present in the right subtree are greater than the root nodes. So elements present in the right subtree over here, this is the right subtree. So elements present in the right subtree are greater than the roots, are greater than my root A, are greater than my root A. So if this condition is satisfied, then we will call it a binary search tree. So what is a binary search tree? The binary search tree is such kind of tree where the left subtrees are less than the root and the right subtrees are greater than or equal to the root. Now where it is used, binary search trees are basically used for searching and sorting applications. What is an expression tree? An expression tree are used to evaluate the simple arithmetic expression. Expression tree is basically a binary tree where internal nodes are represented by operators and leaf nodes are represented by operands. What do you mean by leaf node? We have already seen leaf node will have no other children. So these are leaf nodes. What are leaf nodes? Leaf nodes will not have any children. Internal nodes are represented by operands and leaf nodes are represented by operators and leaf nodes are represented by operands. We will see with an example. Suppose this is an expression. This expression you need to represent in the terms of expression tree. How will you do so? See what we have told you. Leaf nodes are represented by operands. So leaf nodes are represented by operands. What are operands? A, B, these are operands. Over here this A, this B, these are operands. C, D, these are all operands. These are operands. So these operands are represented by whom? By the leaf node. What are the leaf nodes? These are the leaf nodes. So A, B, because there are no other children, so these are represented. And the internal nodes are represented by operators. So which is the operator? A plus is the operator, division is the operator, minus plus is the operators. So let's see how we have formed this. Over here we have A plus B, isn't it? So here I have A, I have B, I have plus. So it becomes A plus B over here. Then I have A multiplied with B minus C. So I have A multiplied with B. So I have A multiplied with B minus C. And these expressions are governed by division. So I have division over here. And this entire thing is added with D. So this is how we have formed this. Now what are tournament trees? Tournament trees are used to record the winning of a match in each round being played between two players. Tournament tree can be called as selection tree or winner tree. So tournament trees are used for what? They are used to record the winners of the match in each round. Now how can we form the tournament tree? Tournament tree can be also called selection tree. External nodes represent the player among which a match is being played. The internal nodes represent the winner of the match. At the topmost level, the winner of the tournament is present at the root. So the winner will be represented at the topmost level as a node. Let's see with an example. If it's just tournament is being played between four players, the winner is in the left subtree will be played against the winner in the right subtree. So they have played, A and B has played, out of which A is the winner. C and D has played, out of which D is the winner. Then A and D played, and A is the winner. So this is how we form the tournament tree. Then we have the binary tree. We have binary tree is a special type of tree. Each node can have at most two children. Obviously, we have to discuss this. The binary tree roots of the left tree, the left subtree is also called a binary tree, and the right binary subtree. So this is a binary tree. What are binary tree? Binary trees will have at most two children. So see, they are having two children. All of them are having two children. So it's a binary tree. Types of binary tree. There are two types of binary tree. One is a strictly binary tree and another is complete binary tree. So what is a strictly binary tree? Strictly binary tree are every non-leaf node contain non-empty left and right subtree. Contain every non-leaf node contains non-empty left and right subtree. In other words, the degree of each non-leaf node will always be 2. So in this, what is B? B is a leaf node. So this condition is not present. Non-leaf tree can contain only should contain 2, isn't it? A is a non-leaf tree, it has 2. C is a non-leaf tree, so it has 2. D is a leaf tree, so this does not satisfy, it is not required for it. D is a non-leaf tree, so it is having 2. So this is a strictly binary tree. So what is a strictly binary tree? A strictly binary tree, the non-leaf. What is a leaf? Leaf will be such node which does not have any children below it. That's a leaf. A non-leaf tree means they will have some kind of children. So every non-leaf tree contains non-empty left and right subtree in the case of strictly binary tree. In a strictly binary tree with n leaves, it will have twice n minus 1 nodes. Now, in a complete binary tree, it is said to be complete binary tree if all the leaves are located at the same level of D. All the nodes are located at the same level of D. So, it will have complete binary tree. Now binary representation. A binary can be represented by linked list. In this type of representation, the binary is stored in the memory in the form of linked list. The number of nodes are stored in non-contiguous memory location. We have already seen this because linked list can store in non-continuous memory location, and they are linked to each other with the help of pointers. So what will my node have? My node will have three parts: pointer for the left node, pointer for the right node, and obviously the data elements. It will have 3 points. So each node will have 3 parts. One of them is for the left tree, one is from the right tree, and this will have my data. Over here, this is A, this is B. So this is how it is formed. Leaf node contains null in its left and right pointers. Obviously, see, it is a leaf. Since it is a leaf, it will have no other value, so I am having null. D is a leaf, so null. C is not a leaf, so it is having some kind of addresses of the next. So as you can see over here, I started with A. Suppose I started with A. It is connected with B. A is connected with B. So where is B? B is at the 9th position. Hence, B is at the left of A. So B is at the left of A, which is at 9th position. So I have B. What is to the right of A? The right of A is C, and C is present in what location? Is location 7. So C. So A will have 9 over here and 7 over here. Next B. B is the leaf node, so it will have no values. It's having null. Minus 1, so it's having null. So it's having null. C is having D on his left. So C is having D on his left. Where is D? D is located at 1. So C is having D over here. And C is having E on his right. So where is E? E is on the 5th. So E is on the 5th. So it will have 5th. So 5th. Again D and E, both of them are having null. So as you can see, both of them are having null. So this is how you formed a memory allocation of binary tree using linked list representation. What is sequential? Sequential is the simplest form of allocation, but it is the most inefficient technique because a lot of spaces are wasted. Let me show you an example. So just see this and let's see. Here what happens is that, let me just give you the points. Here, if a node is stored in the ith index in its left, and right children will be stored in the 2i and 2i plus location. Let me just again rephrase it. Now if just understand this, then we will see the example. If my node is having the ith index, so my ith index, if it is having ith index, then left will have the position of 2i and the right children will have the position of 2i plus 1. Just keep that in mind. Left will have 2i, right will have 2i plus 1 position. So let's see over here. Start with A. So I have A initially, then after A I have B, then after B I have C, C. So up to this it's okay. Now where is B? Where is this B? B is at the 2 position. Then D, which is on the right. What we have said? If it is on the right, then it is on the sorry, D is on the left, isn't it? D is left of B, and if it is on the left, then it will be on the 2i position. B, which is already in 2 position, then what is 2 into 2? The 2 into 2 is 4. So D is located at 4. Where is E? E is to the right of B. What we have said, if it is on the right, then it will be the 2i plus 1 position. So B is in 2, 2 into 2 plus 1 is 5. So E is on the 5th position. Now E is on the 5th position. What is H? H is to the right. 5 into 2 is 10. So H is on the 10. And I, which is on the left, is 2i plus 1. So 2 into 5 plus 1, which is 11. What about F? F is to the left of C. C, which is at 3. So 3 into 2 is 6. F is at 6. And G, 6 plus 1, 7. What about these two positions? These are wasted, isn't it? So in sequential representation is inefficient because a lot of spaces are wasted. So this is how it is formed. Binary search tree we have already discussed. Binary search tree can be defined as a class of binary trees in which the nodes are arranged in a specific order. In binary search tree, the value of all the nodes to the left are less than the root. I told you, value of all nodes is less than the root, and value of all the right trees are greater than the roots. As you can see over here, this is my root node. Everything on the left will be less than my root 30. So 15 is less than 30, 7 is less than 30, 22 is less than 30, 17, 27, all of them are less than 30. And anything to the right is greater than 30. See, 60 is greater than 30, 45 is greater than 30. So this is binary search tree. No, where it is used, binary search trees are used for searching, because searching becomes very efficient in binary search tree because we get a hint, isn't it? Suppose I ask you to find 22. Now you know that since 22 is less than 30, so it will lie on the left side only, so you do not have to even see the data in the right hand side. So aren't you saving the space? That's the reason it is efficient. Got my point? Suppose I ask you to find 7. Now out of all the trees, since 7 is less than 30, you know that it will only be present on the left hand side, so you will not see the right hand side. So that's how it is efficient. In searching, it removes half of the tree, obviously, because I know whether it will write on the left hand side or the right hand side. So that's how it is formed. Here's an example, you can go through it, you will understand it. It's just how the things are formed. I have written there is a C++ code. Just use it. Either you can copy this code or I will provide you with the code. You can write your own code also, does not matter. I just written it for your simplicity. So once you have this, do mention if it is C++ program, then you write C++. If it is C program, then write C. So keep that in mind. I'm entering some random values and it will then sort it in sort. Just go through the program, you will understand it. It's not a very big program. I have written and I've started with a structure. It is having the nodes. This node will have, as I told you, we have two pointers, left and right. Left for your left subtree, right for your right subtree. Then we will create a node. The value we will put it on the data, and the address, the right will left. Initially we will start with null, and then in each order we will then put out the values of the left and the right. So this is all about tree. In the next lecture we will see other things. Thank you.